What is fermentation? Fermentation is an anaerobic biological process that converts sugars and starches into simpler substances. In baking, it causes yeast and bacteria to convert sugars into carbon dioxide, among other things. This is what causes the dough to rise. Besides dough, fermentation is also used for the production of dairy products such as cheese, yogurt, kefir, kumis, hydrocolloids like xanthan gum, organic acids like citric acid, enzymes, chocolate and flavors, vitamins and antibiotics. Where did fermentation come from? The use of fermentation in bread can be traced to the ancient Egyptians in 4000 BCE. In 1854, French chemist and microbiologist Louis Pasteur determined that it was microorganisms in the air that caused food to ferment and spoil. How does it work? In bakery products, fermentation is a complex series of biological reactions that allow dough to leaven. It is carried out by different strains of yeast and lactic acid bacteria. These microorganisms start by consuming simple sugars in the flour and generated by amylase. This produces carbon dioxide and other compounds, which are responsible for the unique flavor and texture of bread. The process starts once yeast or lactic acid bacteria is added to the flour and water, either as individual ingredients or pre-ferments. It continues through early stages of baking where the yeast or lactic acid bacteria is inactivated by heat. The fastest rate occurs during proofing and oven spring stages. What are the fermentation steps in bread making? Pre-ferment. This step is optional. Flour, yeast, water are fermented for a long time. This is essential for the development of unique flavors in some breads and enhancing shelf life. First fermentation, mixing pre-ferments with rest of dough composition. This step may last up to 8 hours in artisan breads. Second fermentation, takes place after the dough is first punched. Proofing, after dough makeup and can last from 1 hour to 1 day. Baking, loaves are expanded due to yeast and steam generation. Here are the ideal conditions for yeast and lactic acid bacteria fermentation in dough. pH, primarily acidic to slightly acidic, 4.5 to 6.5. Temperature, 95 to 113 degrees Fahrenheit, 35 to 45 degrees Celsius. At lower temperatures, fermentation slows down while higher temperatures produce undesirable aromas and excessive acid buildup. Relative humidity, ideally between 50% and 90%. Carbon source, lactic acid bacteria and yeast feed on monosaccharides and disaccharides. Sugar level, 2 to 10%. Higher levels can negatively impact microbial activity due to osmotic pressure. Residual unfermented sugars are necessary during baking for proper crust color development. Salt level, up to 2.5%. Higher levels exert considerable osmotic stress on yeast cells. Water content, absorption levels of 50% or higher, based on flour weight, are optimal. Higher levels lead to faster or uncontrollable yeast activity. Yeast or lactic acid bacteria levels. The higher the yeast or lactic acid bacteria level, the shorter the total fermentation time required to mature the dough. Fermentation and clean label baking. Extended dough fermentation has been used effectively for improving dough development and enhancing bread shelf life. In this context, this process is considered an effective alternative to traditional dough conditioners. So this provides bakers with the means to produce clean label bakery products. Want to learn about different types of fermentation? Visit BAKERpedia. Learn more about all things baking by signing up for our newsletter. Until next time, bakers. At BAKERpedia, we're here on a need-to-know basis.